So this is going to be our next notes in geometry. It's going to be parallelograms, and this is lesson 6.2. And so the first thing we want to know is, well, what's a parallelogram? So what a parallelogram, the definition is, it's a quadrilateral with both pairs of opposite sides parallel. Okay, so we look this one right here. AB is parallel to DC, and then BC is parallel to AD, so this makes it a parallelogram. And then we use these little rectangle shapes to name them. Then we just use letters, so we might have this rectangle A, B, C, D, like that. Okay. So if this one here is a parallelogram, we would then say, like I said, BC is parallel to AD, and AB segment is parallel to DC segment. So we kind of note it as that. Now there's a few important theorems that go along with parallelograms that we can use to help us solve for things we don't know. And one of them is to remember that if you have a parallelogram, opposite sides are congruent. So if we look at this parallelogram here, right, just like we said, what makes it a parallelogram? AB is congruent with DC, and AD is congruent with BC here. Okay, so that's theorem 6.3. And then we can also add the angles. So it says if a quadrilateral is a parallelogram, opposite angles are congruent. So if we have this condition, then we would have the same, just a different drawing. So we'd say B and D and A and C are congruent, just like we wrote here. So that's kind of the first two. Opposite sides are congruent. Here and here, here and here, they're congruent. And then angles are congruent, the opposite ones, BD, AC. So if you want to add another theorem, 6.5, it says consecutive angles are supplementary. So if we have this quadrilateral, this parallelogram A, B, C, D, and we have this one XY, if we add these two angles together, they're equal to 180. And even if we go here, Y and X, they're also equal to 180. And then if we go these two consecutive, XY, they're also equal to 180. And then if we add these two, so as you go around, these angles are equal to 180 degrees. The notation for that is just X plus Y equals 180 degrees. We look at the next one, 6.6. This says if a parallelogram has one right angle, then all angles are right angles. Okay, so let me just say we have this parallelogram. They don't have to be slanted, right? This could be a right, 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 and a right. And even if it only says one of these are right, okay, then we know if this one's a right angle, the rest of them have to be a right angle as well. Okay, let's keep going. So then if we add some other part to these parallelograms, and we use something called a diagonal, which cuts across from one angle to the other, or one side to the other, we can have some new theorems as well. And I kind of left this part I erased, but we're going to start here. Diagonals bisect each other. So if we go a diagonal from A to C and D to B, they bisect each other, which means they cut each other in half. Okay? And then we remember this is a parallelogram, we can tell, because these sides are congruent and these sides are congruent. So then we know if these diagonals bisect each other, we then know AP is equal to PC and DP is equal to PB. Okay? That's another one, 6.7 there. And then 6.8 says diagonals separate into two congruent triangles. So if we just do one diagonal, we then know this triangle ABC is congruent with triangle DBC. Okay? And that's kind of the theorems we can use to figure out for unknowns if we have a parallelogram. So let's look at some ways we can use these theorems to solve for unknowns. So let's say we have this parallelogram A, B, C, D, and we have A is equal to 55 degrees. Let me write that in. And then we also know that AB is 2.5 feet. And then we also know that BC is 1 foot. Okay. So then We can solve for some of these other ones, but if you have this condition where you know this is a parallelogram, you know some things are true. Like these two sides are equal, so we can also call this 2.5 feet. And then we know BC and AD are equal, so we can say this is 1 foot. And then we also know opposite angles, right? So 55, angle A is congruent with angle C, so we know that's 55 degrees. And then we also know that these angles together are equal to 180, so 125 plus 55 is equal to 180. And then we would opposite angles again, 125 as well. So then we pretty much got this triangle filled in. Then it might ask you a triangle, quadrilateral, sorry. We got this quadrilateral filled in. Then it's going to ask us, so what's DC? Right there. So we know if AB is 2.5, this is also 2.5 feet. And that's because AB, segment AB, is congruent with segment DC. Then the measure of angle B, right here, is 125 degrees. And that's because consecutive angles, so that would be a measure of angle A plus the measure of angle B, are equal to 180 degrees. And then we know what measure of angle A is 55, plus the measure of angle B is 180. We could do some algebra, but then we'd come out and see that that's equal to 125. And then also, finally, we could do the measure of angle C, and we know that these opposite angles, if this is a parallelogram, or quadrilateral as well, then they're equal to each other. So this would be 55 degrees. Okay? So that's some things, some basics we can use. If we just know a few things about a parallelogram, we can figure out a lot of different sides on that parallelogram. Let's look at one more thing we can do here. So then if we have this condition, so we're a little bit more complex. So we have this example here. So we have this parallelogram, QRST, and we have some lengths here, and this is a bisector, right? And we know that this is 95, this is 33, okay? Looks like we have an angle here, 32. Probably should be 33, actually. I'll look here in a minute to make sure I got the numbers. I might change that back to 32. But then we know this side is 27. So there's a couple things we could do here. We could say, if these two sides are equal, we could then say 5x equals 27. Okay? And then we could divide by 5. And then we could get x equals 27 divided by 5. And then if I used my calculator. Okay, so then we'd find out x is 5.4. And then we have some 2y minus 5 is y plus 4. So these are bisectors, so they should be equal to each other as well. 2y minus 5 equals y plus 4. And then we do the math. So this will be minus 1y. That'll give us y, and we'll add 5 to this side. So y is 9. Okay. And then we can plug in, this one side, 2 times 9 minus 5. So that would be 18 minus 5 is 13 for that side. Then we just want to make sure the other side is the same. So I go minus 5, 18. And then the other side is y plus 4. And y is 9 plus 4. And that's 13, so that works as well. And then we got a z here, I think. I think it's 3z actually, not 33. Okay. And then, so one other thing we can do here is convert these angles, because we know these are opposite angles, so they should be equal to each other. Okay, so this last piece here, we can figure out z then. So we've done x, we've done y, and then we can do z. So look at this one a little bit differently here. So we're going to compare a few triangles here. And we know if we just have one bisector, like maybe right here, we could cut this triangle in two. So if I go, maybe we just use this one right here. Okay. So if we use that one, we get rid of this one. Right. So then if we have this triangle right here, and then we have this triangle over here, right? So these sides should be equal, right? these sides are shared, so they're equal. This side should be equal as well, right? Because it's a parallelogram. So then we would think if those are all equal, that these two angles should be equal. So then we'll do 3z equals 33 divided by 3, and then z equals 11. So that should give us our answers 5.4, and then 9 and 11. And that should be a way we can use these properties of parallelograms to figure out things that we don't know. Now tomorrow in class we'll actually do a coordinate system, and we'll put one of these parallelograms into a coordinate system and solve for some things as well. So we can do that in class tomorrow together. We'll review a couple of these as well. Make sure you add these to your notebook, and I'll see you in class tomorrow.